Hi, engineers and professionals. Welcome back once again. I am thankful for your comments and interest in my earlier videos. So, keep on encouraging with your feedbacks and responses. In this series of videos, I will be covering all the stages of EHV and HV substation construction projects. Will try to share my experience and knowledge stepwise involved in the projects from the project management point of view, and this knowledge is helpful for the project team like project managers, project engineers, project directors, site engineers, site supervisors, even the technicians. This series of video, hopefully, depending on your response and the requirement, will be covering all the steps like planning, procurement, installation, civil works, testing knowledge, equipments used in the testing, stakeholder management, and other applied project management expertise. This will also contain some videos for the actual installation of the project, like earthing mesh, installation of medium voltage switch gears, cable tray installations, cable pulling, cable terminations, ferrule reading, drawing readings, which are required the site activities. This will also be covering the project management concepts which are applied in actual projects. So I would like to highlight here that these videos will be from the contractor point of view. Client is the one who will provide you the minimum requirements which you have to follow, and contractor has to do and meet the minimum requirement as well as following the SEC standards or DEWA standards depending on the location where this project is being executed. So I will be covering the steps from tendering till the project handover of such companies like Saudi Electricity Company and DEWA. So this is going to be a very interesting and useful series of videos. So subscribe and share your feedback most importantly. Today in this video we will be completing our some of the topics from the single line diagram. Last time we discussed about the GIS 110 kV voltage level, and this time we will be proceeding for the next step, which is the transformer. If you will go, I will show you the single line diagram. Here we discussed the input from the 110 kV GIS is given to a transformer, power transformer, and output from that transformer is fed to the medium voltage switchgear. Here three transformers are there. I will just quickly repeat, and three bus sections are there. So these three transformers are having some technical details which I will discuss in the next slide. And further, the configuration here for from the transformer up to the medium voltage switchgear, we have three transformers which are connected between HV and MV switchgears through cables. And medium voltage switchgear consists of three bus sections A, B, and C, around 35 outgoing feeders which are feeding to the load, and two auxiliary transformer feeders and three capacitor feeders. We will explain more in details about the MV switchgear, power transformer, station service transformers, capacitor banks. But in this video, to keep it short and informative and to avoid the lengthy videos, I am making small videos covering the each component. So in this video, we will be covering the transformers. Let us zoom in this area for the clear visibility. Here you can see the extract of the single line diagram and the picture of the same transformer. So let us open it and let us go into some details which are required for a project manager or a project team to understand. So here this is shown. If I start from this point, the 110 kV single core 400 square mm cable is connecting from GIS to transformer. Okay, this cable is, you can see in the picture, is connecting with these bushings. These are the bushings, air bushings, and the cable is connected with this, and further connections are done with this triple AC conductor 110 kV 1 into 500 square mm. One single conductor, its diameter is 500 square mm, and it is triple AC conductor 1, 2, 3 going to the primary of this transformers. So this is showing the drawing and this is showing the actual. If you go further, you will see the surge arresters. Then from surge arresters, it is going inside the body of the transformer, and this is star star connection. Primary is star, secondary is star. You can see here BCT 1, 2, 3. These are bushing CTs, and BCT 4, BCT 5. Some of the CTs are on the primary side, some of the CTs are on the secondary side. Some of them are on the red, yellow, blue phases, and some of them are on the neutral side. So this all depends upon the requirement of the protection, because you know the transformer is the main equipment in the substation. It has to be protected. It's very expensive equipment. I think the most expensive equipments in the substations are three. One is the transformer and other is the GIS. So we have to protect this transformer and GIS through a third equipment. Third protection means that it's called control and protection. So in any project, we have to invest sufficient amount for the protection of these equipment. So these CTs are actually used for different type of protections which are applied in the transformer protection, the mainly differential protections, sensitive earth fault protections, restrictive earth fault protections. So you can see here the neutral of this transformer is solidly grounded through a cable 1 into 1 core 630 square mm XLP cable, and it's a 110 kV voltage. This is the same cable which is uh, higher dia like this XLP cable per phase, but here this neutral is single cable is running from the transformer neutral bushing to the solidly grounded. The secondary of this transformer, this star is shown here grounded through NER, neutral earthing resistor, depending on the technical requirements of the project technical specifications. So now you can see also here one delta. This is called the tertiary winding, and it has also some protection CTs are there. So let us go and read this part. This is the main part of the transformer showing its rating characteristics. Let us see. The first line is showing 110 by 13.8 by 16.6 kV. This denotes first the primary 110, secondary 13.8 kV, and tertiary 6.6 ohm. The tertiary winding is to provide improved system stability, load management, and harmonic handling. Sometimes we are also using the tertiary winding for the smaller loads, to feed the smaller loads, but this is very small compared to the primary and the secondary of the winding. Next thing is coming the percentage impedance. The percentage impedance is defined as the percentage of the rated voltage applied to the primary to get the full load current, while the secondary is short circuited. This is the characteristics required from the project technical specifications, and the transformer manufacturer has to meet this one, or he has to get it approved from the client before manufacturing. Then comes a concept of tap changer. Tap changer is actually to regulate the voltage when the transformers are more than 1, 2 and they have to run in parallel. Their voltage regulations should be the same. The output voltage of the both transformers should be the same. So for that reason, to make a parallel operation of transformers more than one, sorry, so you have to raise and lower the voltage. And also sometimes not only for parallel operation, sometimes due to the load conditions, the transformer voltage drops. So this step position will increase and decrease the voltage to meet the required voltage. For example, we need now here 110 kV voltage is a constant voltage, but due to some load conditions, the voltage can drop or voltage can increase. So for that reason, we have to raise the tape and we have to lower the tape according to the situations. So this raising and lowering is done by an OLTC. OLTC is on-load tape changer. It is an automatic device controlled locally from the transformer, can be controlled remotely from the SCADA system or from the control room or from the HMI, the SAS. The new modern substation is having a substation automation system which can control also such kind of functionalities like OLTC. In normal transformers, small transformers, these OLTCs are actually offload and they can be done manually. Like in this substation, in auxiliary transformer, the tape changer is manual. So next is coming the very important factor, that is the vector group, this yn 0. Let us explain it in a quick way. Yn 0 plus d1. First capital letter Y shows the primary of the power transformer which is connected in star with the capital N as a neutral. This Y and neutral. You can see here, this is Y and this is neutral. And the small, this is the primary side. The secondary side is Yn, small letters Yn. This is small Yn. This is the neutral. And 0 means these both quantities, both voltages will remain in phase with the 0 displacement. So this is a vector group for Yn 0 for the primary and secondary. For the tertiary, it is a D1. D is showing that the winding is in delta connection and 1 is showing the 30-degree phase displacement. So you can go into the details how these degrees are calculated. So 1 is equal to 30 degree and 2 will be like 60. So depends on the requirement. So now here this transformer is now designed and manufactured, and as a project manager, this is the responsibility of a project manager to design the transformer according to the project requirement and technical requirements. After getting the approval of this design, the project manager is issuing the manufacturing of these transformers, and he has to construct the foundation for these transformers from civil point of view. A project manager must do the procurement, design and installation arrangements, testing and commissioning for these transformers. So mainly this foundation is done by a civil team and installation is done by the electrical side team. So this transformer, after having the foundation, is having some marking on it, and these should be in matching with the dimensions of the transformers. So this is the for now for today, and in the next video I will be covering the medium voltage switchgear part of the substations. Thank you. See you in the next video.